Okay, example 3, it says simplify 3 to the 5th times 3 squared. Now, the rule that we're going to be using here is the rule that says when you multiply x to a power times x to a power, you're going to take that x and add the powers. Okay, and what bothers people about algebra is a lot of times they take these rules that involve letters, and you need to generalize the rule to deal with anything of that structure. So even though this doesn't say x to the 5th power, it's something to a power being multiplied by the same thing to a power. So the requirement of the rule is the bases have to match. If they do, we're going to write the base again, right? So when I do 3 to the 5th times 3 to the 2nd, I'm going to write 3, not 9, but 3. And then the rule says what I'm supposed to do after I rewrite the base 3 is I'm supposed to take this power plus this power. 5 plus 2 makes 7. Three to the 5th times 3 to the 2nd makes 3 to the 7th. Again, it does not make 9 to anything. Okay. The rule does not say x times x equals something other than x. X times x equals x. 3 times 3 equals 3. Power plus power is what you put on the answer. What?
What happens if it was like division or subtraction? Would it be the same thing then?
If it were division, then you're going to be subtracting the powers instead of adding the powers. But again, if the same number were happening, for example, if you have 3 to the 5th being divided by 3 to the 2nd, that makes 3 on top because 5 is bigger. 5 minus 2 makes 3. Okay. So division, subtract powers, multiplication, add powers. All right? Now, my thoughts on 3 to the 7th power, that's probably simple enough. If the number is going to be less than 1,000, maybe I'm going to evaluate it. But if I try doing 3 to the 7th power, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729, times 3 is 2,187. That's 7. So what?
What if both of the top exponents were 2, 2?
So if you said, what if it's 3 squared times 3 squared?
Yeah.
Again, the rule says that if the bases match, you rewrite the base, and then you add the powers. 2 plus 2 makes 4.
Okay. So if it was 3 times 2 with the same exact exponents, it would be...
So now you want, like, if you have 3 to the 3rd power times 2 to the 5th power, something like that?
Yeah.
Those are different, right? There's no rule for what to do when they're different, so there's nothing else you can do to that one.
And you just leave it like that?
Yeah, you'd leave it like that, or at best you could evaluate 3 to the 3rd power is 27, 2 to the 5th power is 32, get them down to regular numbers, and then evaluate with a calculator. But there's no way to make this into some smaller thing like this, because the numbers don't match. Again, the rule requires that the bases match.
All right.
All right? Any other concerns?